Let's create another example for debug. We'll go ahead and remove that second rule. And what we're going to do is create a plane. It's actually going to be facing a particular direction. And we're going to create another rule under the master dynamic that is going to affect the all particles. We're going to need a node because we're going to use a dynamics operator called UDeflector. And UDeflector is going to detect when a particle hits an object, and we need to pick which node we want to know if we hit. It's going to be this plane, and so UDeflector, he's got a whole bunch of outputs here. What we're really interested in is this collision output. It's a Boolean, so whether or not a particle has hit something at this particular time. And what we want to do is we want those particles to die when they hit. So we need to know which particle to affect and when, so we're going to expose the on parameter for particle die, and the particles are going to die. This will get switched on when the collision happens. Now you can see that this face ID lights up. It means it could be a valid connection, or the data type would allow it to be valid, but yeah, I mean face ID, whoops, let's recenter ourselves there. The face ID would be coming off this object. It's more useful for sticking particles on objects. So really we want this on to be controlled by the collision. So I know, more information than you need, but there it is. Okay, so here come the particles. They fly out. Oh, you know what? They don't really live long enough to really get there. Let's set the particle draw life to 100, and we'll set the velocity to be a little higher. Okay, and here's a great example. Now, the reason this is happening like this is because the plane that we created, the faces are pointing out this way, so the face normal is not facing these particle directions. And that's very important when it comes to UDeflector. UDeflector has a switch here for front side or back side or two-sided. But one of the ways we want to use this debug to see what's happening is we're going to expose the collision output. So we're going to right-click and say write to debug log. Now as we scrub forward, you can see that the UDeflector operator is outputting collision information, and that value is 0. There's no collisions, no collisions, no collisions. So even as those particles pass through, we still see no collisions. Okay, so let's go ahead and we can tell that we need to turn on two-sided because obviously it's not working. And now, as we scrub forward, we'll see, boom, we see this UDeflector collision equals 1 as that particle hit there. And we'll watch what happens when this particle here comes forward. 0, 0, 0, 0. And remember, this green interval here is telling us we're at ticks value 8480, which is 53 times 4800. And the change in time since the last frame is 160 ticks. So, and here we are, we're about to collide, and almost there. Okay. So debug is very useful for seeing what kind of information each particle holds and using it to debug that. Let's take a look at another example using debug. Here we've got a scene that's got these particles being drawn at different times, and when they're drawn, they're given some velocity at birth. They're assigned a cube shape and a size of 4. What we're going to do is we're going to go ahead and add a data channel to this all group, and we're going to name that channel my age. It's going to be a float data type. We'll go ahead and add that. You see now we have a data at ch0, channel 0 is named my age, and it's a float type. We'll go ahead and create another rule, and in this rule what we want to have happen is we want the all particles to update their data channel value. And in order to do that, our data channel operator here has a parameter data channel. So this is going to affect data channel 0. Now data channel 0, of course, is a float. So the data channel operator, we're going to expose the float. You could actually expose all of them. but anything except a float that you wire in is just going to be ignored. And what we want this rule to do is we want the particle's age to be updating this data channel. So we'll expose the age, drop that into float, and because this data channel does not have an explicit on controller, it's just going to be updated every frame or every time sample. Now we can't really see that effect yet. We're going to do something else here. We're going to create another rule. It's going to affect the all group, and we will have it set particle size. And the way we're going to do this is we've got this all group. He's got a data channel 0 called myAgeFloat. We're going to expose an output, and all data channels are available as outputs you can expose. So you see the ch myAge, and we're going to connect that to the size. So all size is now going to be driven by this data channel called myAge, and that data channel is being updated by the age every frame. So what will happen is, as he gets older, he's going to get bigger. So let's actually take a look how we can use debug to see what's going on exactly. We'll go ahead and do a right-click debug, and so the all's age is going to be exposed when we turn on debug. Now that first guy is born at 0, so this first thing here tells us that it's the all group that we're looking at, and his age output, that's the asterisk age, and we can see that his age is in the format frames equals 0, ticks equals 0. So as he comes out and gets older and older, you can see him turn 20, turn 21, and we also have this other particle that's been born, and we can see his age coming out here. Now in order to actually see where the size is being set, we're going to come to this size operator, right click on the size and say write to debug log. And now the size value is also going to show up here per particle. So we've got, let's get out to frame 06 or something. We've got only one particle being born, and this first debug, the age equals, is being exposed here. Comes out, shows us how old he is in frames and ticks. And then also during frame 6 we get another output from the next rule, because remember these are processed sequentially top down, and we get the size input is going to be shown what value is coming in there. It's actually the age value. So that all makes pretty good sense. Debug is a great way if things just don't look right or they don't seem like they're behaving right. Make sure a value is being used and then expose it and see what that value is. It's tremendously helpful for troubleshooting.